Okay, sorry to interrupt that video in midstream. Thatcher the Bloodhound was howling at somebody outside. Okay, where I left off, we said that as we start to vary the objective function coefficient of S2, this is our function of reduced costs, which is in terms of delta, which is delta here is the amount of change in that second objective function coefficient. And we said before, in order for the current basis to remain optimal, we need these reduced costs for a maximized problem to be non-negative, greater than or equal to 0. So the question is, what values of delta will, in other words, leave these reduced costs to be non-negative? And you can see that the first one is not a function of all of delta. So basically this reduced to the question of when is 0.333 minus delta greater than or equal to 0. You can quickly compute that delta needs to be less than or equal to 0.333. Okay, so that would have been a fine answer. You could also say delta could range from negative infinity to positive 0.333. So, and you can sort of communicate in a variety of ways. But that was the answer to this part II of the fourth question. Now let me go on to part III. Back to the problem sheet. It says now what we're going to do is we have a new constraint. New constraint is 2x1 minus x2 greater than or equal to gamma. If this enters the LP, the question asks you to determine the maximum value gamma could take in order for the current solution to remain optimal. Okay. So let me go back to this scratch paper. Basically what you needed to know for III is that when we add a constraint, all we need to do is check whether our current optimal solution remains feasible. Okay, so let me write that out. If we add a constraint, all we need to do is check feasibility. Okay, now I saw some people doing this by sort of constructing a new B matrix and computing B inverse B. But really, you can check feasibility much easier. We know the current solution is feasible for the current set of constraints. So in order to check feasibility when we add a constraint, all we need to do is check feasibility for that specific constraint. So in other words, we've got 2x1 minus x2 greater than or equal to gamma. And the question is, what are the values of x1 and x2 at the current solution? Well, let's look back. One of the pieces of information was provided was B inverse B. Okay, that's the current basic variable values. And if you looked at B or C sub B and looked back at our original formulation, it was pretty easy to see that our basic variables were x1, x2. Okay, so that means that B inverse B are the values of x1 and x2. So let me go back to my constraint. That means my current x1 and x2 values are 3.33 and 3.33. So the question is, when is 2 times 3.33 minus 3.33 greater than or equal to gamma? Well, this is just 3.33. So the question is, what's the maximum value gamma can take in order for this this constraint to hold? And you'll quickly see that it's gamma max, let me call it, would equal 3.33. And that was all you needed to do for this last part. So again, there wasn't too much computation on any of these because I don't think that's something I'm trying to test in the exam.